シャルエンバイロメントなんですけど、how to categorize a special environment? It's difficult to categorize. But まあ space, field, disaster. So therefore space. One is a space. まあ underwater とか underground とか。It's difficult to access for human. So therefore, in place of the human, the robot or some remote operated machine or autonomous machine will do some task. Pipe is also one inside the pipe is also one area to difficult to access. So therefore, some robotics equipment is used to inspect inside the pipe. とか、オープンフィールド。フィールドはなんかオープンエアフィールドとか、some various field。フィールドの下に、わかんない。ちょっといつできか。フィールドがあって、なんかパイプラインもフィールドの一つかな。あるいはなんかオープンエアフィールド。And so the unmanned construction, unmanned recovery, maintenance will be done, and especially in the disaster field, some volcano or some accident, after the accident, earthquakes, and also tsunami, also there. So therefore, some machine robotic system will be used. So firstly is started with space. Space field. This is example. ETS is more than 15 years ago. National Space Development Agency, NASA, NASDA is at that time, but today is JAXA. JAXA ね。
Space Exploration.
JAXA. Japanese Agency of Space
Exploration Agency.
Agency, yes. So formerly it was NASA, and presently is JAXA. Is launched the engineering. ETS means engineering test satellite. The various tests has been done. Especially in this ETS 7 is doing this release and capturing the docking again. This test is the rendezvous and docking. Yes. Firstly, it is released and rendezvous and docking, capturing small satellite. Is this test satellite's mission. But in addition, you can see this is some robotic arm is here. So robotic arm teleoperation test is also has been done. Space robot technology test, remote operation of manipulator arm from the Earth ground has been done. So what is a difficulty? What is a problem for this kind of remote operation?
Manipulation.
Of course, manipulation. So the robot だからロボットアームマニピュレーションだよね。で、what is the problem of this kind of remote operation?
Conditions.
Connection?
Environment.
Environment condition. Environment condition. Some heat or cool. When the sunlight is applied, it is very heat. But after, for example, in the behind of the planet, it is very cool. So the temperature is fan is very high temperature and low temperature. So the bandwidth of the temperature is very wide range. Yes, this is one. More.
Maybe connectivity to the satellite itself, maybe I got this connection many times.
Connection? じゃあなんかインフォメーションとかインフォメーションコネクションとかトランスミッションコネクションとか
Maybe.
But for manipulation, for robot manipulation.
No gravity.
Eh?
No gravity in the space.
No gravity is good to manipulate. No gravity because the robot has to produce some additional torque to move itself. Only inertia is applied to the robotics arm system, but don't necessary to think about the gravity of itself. Yes? And remote operation of robot. You remember? Robot remote operation. What is the problem? Hey, look. What? From Earth. From Earth to satellite. What is
Feedback.
feedback? Which kind of feedback? Yeah.
Like, what's the word for it? Contact feedback. That, like when
And some information, sensing information.
sensing information,
Position.
position feedback,
Position feedback and the force feedback or tactile sensing feedback. Various kind of information should be fed back, of course. And Asifa, something you remember? One answer is long distance, so therefore long time delay. Distance, for example, this is some orbit, but on the moon, on the Mars, more longer distance, so therefore make some time delay longer.
I can consider it under connection, maybe.
Eh?
I can consider it under connectivity or connection.
Connection is one thing, but it is connection using some direct connection is necessary, or hence behind this plant, you have to use another relay satellite to connect to each other. So therefore but one of the distance, depending on its distance, the go and back feedback time delay will be increased.
Real-time performance.
So it is difficult to real-time operation. Sometimes, for example, stop and wait and information feedback, and then again the move and stop and the result will be captured again, and then stop. So stop and move. And this kind of operation makes the maneuverability or operability reduced, performance, workability reduced. So therefore, one of the important points is the time delay. How to overcome this time delay for real-time operation or some maneuverability. This distance and time delay is one typical time delay problem. And
Carrier, communication carrier.
communication channel, yes?
Steady state error should be there.
Error?
Error.
What's the meaning of it?
Like there will be mistakes in actual manipulation.
So the remotely, so the when some unexpected event happens, it is difficult to recover in some cases, of course. But also, for example, position information or force information, tactile information is only some numerical data. But for example, image information has more large amount of size. So therefore, it's very but in many cases, the most teleoperation can be done by watching it, looking it. So the image feedback is very important to operate something. But this information has large amount of size. So therefore,
maybe I use compression.
Yes, compression is also used. But if you use position information, force information is more small size.
Yeah.
So therefore, if it is independently, separately, the send and the feedback, the position force command is more high speed, more frequently, but image is not so frequently refreshed. For real-time image feedback, it's less frequently. So therefore, the for operation なんだっけだからオペレーターがこういてオペレーターがジョイスティックとかをオペレートしていてであとイメージとかディスプレイ見てるよね looking at some display でこのジョイスティックオペレーションは more frequently, more rapidly, but the image is delayed, more delayed. So some senses この sensory information, kind of sensory information だからポジションとかポジション force is more frequently, but image is not frequently. So at the same time event the feedback data is not come to feedback to the operator. だからposition is feedback correctly, more rapidly, but image is not refreshed. So for human being is necessary touch and yes, touch condition we can watch, touch feeling we can feedback, but for remote operation, the touch sensor is feedback to the operator, but touch condition we cannot see. So the different information, different sensing information is necessary at the same time, but in some cases the image data is more large amount of, so therefore it has more delayed. So it's a little bit funny feeling for operator. You may understand. So this kind of このnot simultaneously feedback. So this kind of feedback is important, but the simultaneous feedback, parallel feedback is important to improve the maneuverability or operability. Okay. That's clear? Okay. これはそのテストのビデオで、これはイメージデータで、これもイメージデータで、これは3 dimensional simulators、これも3 dimensional simulator で、in this case they have done this model based teleoperation system because the test satellite robot condition can be modeled completely. because no external obstacle. So therefore, the completely this can be modeled. Yes, this task, this workpiece and the robot itself can be modeled. So this image is sent back to the operator with time delay, but this the three-dimensional model image can be fed back to the operator directly, less time delay. So therefore, the operator can do some operation task, remote operation task by watching this simulator images. In this case, that's way. They have tested this way. This is called the model-based teleoperation system to compensate time delay condition. Okay. いいですか？はい。次、なんかローバーっていうのも、マーズローバーって NASA のマーズローバー very famous. And also ちょっとマーズローバーのビデオ知ってみますか？なんでこれないんだ？ちょっとこっちか。
What's up, guys? Welcome to Wasted Space. I'm back in Space Engineers, and I'm back from my break, raring to go. And I thought the first thing I'd do is talk a little bit more about the vehicle that was in the background of the channel update I released just before I went away. So for those of you who didn't see that video, there was a rover-type craft in the background that was loosely based off the Mars Curiosity rover, which uses a specific suspension setup called a rocker bogie suspension setup. And what I wanted to do was see whether or not that sort of translated into Space Engineers in a way that worked. And I've been pretty pleased with the results. Let me dive in and show you what is kind of a version 2 of that now. It's had some changes since the version that was in that video. And the first change I made was making sure that it can be accessed from on the ground without the jetpack. So as you can see, it nicely holds itself in position, ready for boarding down below. And then when you do get in, you can unlock and let the entire thing move itself back around. It's kind of balanced so it sits nice and level, nice and horizontal in there. Now this is set up at the moment in a world that has natural gravity on, and this is because I've been trying to model what it's going to be like when we do actually get on planets. Everything is being affected by gravity on every block. But at the same time, this does work without natural gravity as well. So if you just peek underneath, you can see there's a whole bunch of mass blocks. They're important to keep us nice and stable and level, but they're also meaning that it will work in standard modes without NG as well.
まあいいや、これもまあシミュレーターでこれはa little bit special configuration, 6 wheels here. Why it has 6 wheels? これはこういうのがこうあって、それにさらにこういうのがくっついてるんだよね。So based on this configuration でここら辺がこう動くんでね、it is moved, it can be moved. So therefore it can attach to the very uneven the ground surface. Well, this is one way. But you may note in some, for example, the vehicle, there also has some なんだ例えばこうクローラーってあるよね。クローラー is also used to move. ね。Tanks. Yes. Tanks. What is the feature? These 6 wheels type and tanks. Crawler. まあ compensate weight.
More flexible?
これmore flexible だよね。
Suspension?
To overcome obstacles?
まあサスペンションとか it's better だよね。
Yes.
これはもうハイスピードだよね。more rapid speed movement.
And more load carrying capacity.
だからこれだから load capacity.
Load capacities.
Yes.
This is for more flat areas.
Yes, more for flat areas, more uneven areas.
Yes, more uneven areas.
And this is also one way to, yes, this is wheel type. This wheel. But this system has some special wheel. ちょっと待って、それはどこで見えるの？
Having grip on the road.
トライスター4は東京工業大学の広瀬教授のグループが月探査ローバーとして JAXA との共同研究の一環で開発したロボットです。中心と左右の三輪で構成され、左右の車輪を支えるアームは根元の部分で回転するため、転倒しても起き上がることができ、傾斜面では姿勢を安定に保持して走行することが可能です。
月面でその岩石のサンプルを取って持って帰ろうと思って。
これは何ですかって言ったら、これはクローズね。クローズバンベルトで、あとこれがスプリングね。プレートスプリング。プレートスプリングこうあって、so therefore this is not through circular disc shape, but it can attach to the ground shape. And these edges is produce the frictions to overcome some obstacle or go forward. So this kind of mechanism is developed by Professor Hirose at High-Tech. He has already retired. Yes. This is special mechanism is developed by this laboratory. So I have shown this. So not only, this is also, but not only circular, but this can be the deformable wheel. Deformable wheel is also developed here. これは NASA の例です。NASA の例がちょっと見ますか？
This is our robot razor, and I'm going to be driving it around and showing you some of the things that it does.
30分ぐらいか。
We're in the Kennedy Space Center Swamp Works. This is the GMRO lab, part of the Swamp Works that you're looking at downstairs. That's where we develop robotics for working with resources in space, on asteroids, or on the moon, or on Mars.
The goal of this robot is tied to an idea. It's a mission where the robot would be coupled with a lander, and on the lander would be a processing plant. That plant would be processing dirt. The rover would deploy itself off the lander and go out to the dig site and use its bucket drums and dig and collect the dirt and then deliver the dirt back to the lander, and then the lander would actually do the processing, which would extract.
ということで、this is the rover. You may see the rover, but the rover, various rover is there. Various type of mechanism is used. Because why it is? There are many problems. Yes, for example, this is and also the
environment.
こういうディフォーマブルエッジとか、こういうのもあるし、こういうみたいになんかこんなギザギザホイールとかいうのもあるし、many various kind of mechanism is developed and proposed. それなんかな、アプリケーションオリエンテッドっていうのもあるし、アプリケーションとか、if you think some conditions, environmental conditions, and so on. So therefore, which kind of condition it is estimated and developed, which kind of condition it is estimated, and such kind of specification of the mobile robot spec and so on, which is what is the target, main target of this robot. So due to this kind of reasons, the various kind of mechanism is developed, has been developed. It's all of them are rover, but various kind of rover is there, or not only one type. ね、まあいいや。ということでこれこうが終わって、でスペースロボットっていうと next I estimate that ロボノート、ロボットアストロノーツね、ロボティックアストロノーツ。So the human robot has been developed by NASA and General Motors at about more than 5 years ago. ちょっとどっか短そうなやつ、これか。
Would you rather have robots exploring space or people? Let us know over on Twitter. Find the show at DNews. You can also find me if you want to say hi. I'm at Prof.
これが終わっちゃったなんか変だね。
Let's face it, NASA can hold all human astronauts. Look at Robotics. So, can you tell me a little bit about why you want to send robots into space as opposed to humans or with humans? I guess both.
So we definitely want to send robots into space with humans. The human aspect is very important to human spaceflight and to spaceflight in general. So, humans are much more capable of doing detailed exploration work than robots. However, robots can serve as an incredible assistant to those humans in the right environment. So part of the reason that we want to send robots to space with people is to assist them. So for example, we can have robots do jobs that are either dirty for humans or dangerous or even just dull and repetitive. So there's several reasons that we would want to send robots or robots in general to space with humans.
So that sounds not unlike having robots here on Earth. We're using them for jobs that maybe would be too difficult or too taxing for a human to do either repeatedly or at all. You were mentioning earlier that the robot was better at taking certain measurements than the humans were. Could you kind of expand on that again?
So one of the tasks that we actually had Robonot do as a demonstration on the International Space Station was to hold a probe. So we can basically tell the robot to stop and go whenever we want, or to pause or freeze. So we were able to use that to our advantage in taking a measurement that required or would require a human to be very, very still as they're taking that measurement. But for the robot, we could just pause it and tell it to freeze in its position, and then it's not going to move unless it's acted on by an external force. So basically, it's going to stay in the position that we leave it.
So why make them humanoid? I mean, other than the fact that they look really cool, but why humanoid robots? I mean, instead of more specialized task robots.
So the human element of the robot actually makes it capable of working in the same environment or the same workspace as people, which gives us an advantage because we don't have to have specific robots for every single different task that we might need to perform, or we don't have to have specific tools for every task that the robot might need to perform. So this robot is capable of working with the same tools or very similar tools as humans. So in the spaceflight environment especially, that's important because we don't have room, we don't have mass to send up special tools for the robot to use that are different from humans. So that's one advantage to having the human aspect of it. And the other is that it can work in the same workspace or environment as people. And so even though this robot is a little bit bigger end of the human spectrum, it can still work generally in the same environment as people versus very large robots that maybe are performing much more specific tasks. In the factory environment, they're lifting things that are a lot heavier, things like that. But this robot is very capable and also fits the profile that allows it to work in the same environment as humans.
というわけで何か言いたいかというとね。で、so therefore it is developed the humanoid astronauts, robot astronauts. So therefore, firstly, they have developed this hand and to control the panels. Many kind of various, so many kinds of switches is there. The human finger, human astronauts is doing this kind of tasks. So therefore, the NASA and the GM is developed firstly the fingers, hands, to treat this kind of panels, switching and something, various kind of finger is developed by firstly. And then presently human robot is developed and tested at the International Space Satellite, Space Station. Why this robot nodes is developed? Yes, this girl has explained about that. But human operator human astronaut also necessary. But the NASA wants to replace the robot astronauts as much as possible because もちろん cost is very important and human's life is very important. So therefore, many risks to go to the space and go back to the ground. So therefore, the robot astronauts can do that in place of the human astronauts. It's better by human astronauts. And especially one important point is when the human astronauts doing some tasks outside of the satellite, it's a little bit dangerous presently because presently there are so many space debris is there. So the possibility to attacked by this space debris is increasing now.
China has an maximum space debris.
Yes, so many satellites is launched and it is destroyed and tested and stored. Only remained in the space. So therefore, many kinds of debris is now on the space in the orbit. Yes. So the NASA also inspecting some of them. Some of them is the watching and exploring and taking care. But the less than 10 centimeter, it is difficult to observe from the ground. So therefore, more smaller pieces of debris is there in the air. It was flying very rapid speed. It is sometimes destroys the satellite also, and sometimes it kills the astronauts.
There's a Hollywood movie called Gravity.
Yeah.
Same story.
Yes.
Space debris came and hit the astronaut and died.
So therefore, the space astronauts is there. Robot astronauts is necessary to do some tasks. Yes. And this is another version. Next version. Valkyrie is done about the DARPA's auto challenge. ちょっとこれ見ますか？これなんかアセンブリングところで。いや、こういう面白いんだけど、いいですよ。ロボットハンドでつけられるけど。いや、if you have some time, you should watch later. Yes, なんかリビングタイムはあんまり少ないな。30分か。フィールドロボットね。だからなんかパイプインスペクションはだからパイプインスペクションもだからvarious diameter size and for some このなんだ the curvature, the straight and the T shape or S shape or something is there. So the various kind of mechanism to attach and move inside of the pipe is developed. One difficulty is, yes, testing is this kind of quite new and smooth pipe is used. But actually, after usage, it has some obstacles is there inside of the pipe. For example, yes. For example, in Japan's nuclear power plant, Japanese nuclear plant is built at the seaside, mainly at the seaside. Why it is?
Cooling.
Yes, cooling water is used to sea water is used for the cooling. This pipe is also has to be inspected. Cooling system is also inspected. But by using the sea water,
Salt, present salts.
yes,
Impurities.
so yes, also some materials is inside of this is sea water. Yes, it's okay. One is not pure water, but also the sea water has some many living creatures is there. So therefore, the inside of this pipe, the seashell is there. Seashell. So therefore, the inside of the pipe, there are so many seashells is mounted in here. So it's a for the robot inspection system. This seashell is very difficult obstacle to move. Yeah.
Stick to the shell.
Yes. So yes, in tested it's okay, but actually there are some obstacles here. So therefore many failed. Many cases failed. Yes. So for example in yes, I have shown this right now. これ inside of the nuclear power plant のその福島プラントの one robot developed by inspection the condition of the present debris of the nuclear materials, watching it. So this debris is tested by water jet system to remove it. But yes, this kind of uneven condition to move. So therefore, it is difficult to move to go forward. So therefore, one robot is occluded and not to high radiation force robot to pull out the damage reactor and the main component and the robot to Flavia after probe failure. Not only the probe failure, but also the robot itself is failed. And many robots is remaining in the reactor building. 例えばこの東芝ロボットって言ったんだけど、このなんだっけ、スパイダーロボじゃなくて、このロボットリモートオペレーションシステムでこういうの作ったんだけど、でここに inside of this by using some kind of crawler system is used to move. But test operation, this is a smooth condition. But actually, they are very different from this ideal condition. So therefore, they say that in the crawler, inside of this crawler, some debris piece is is inside of this, so therefore this crawler cannot move. And it is remained in the reactor building now.
So they cannot pull it out?
Yes, cannot pull it out. They have confirmed that the present condition is not good. So therefore they decided to cut the cable and release it.
Give up.
Give up.
Vacuum suction.
Yeah, I don't understand exactly, but they say that it is not pull out.
One in, no out.
So therefore it is cut it and only cable is
One
pulled.
in, no out.
はい、できた。まあまあそういう話ですよ。来週もちょっと待ってくださいね。で、だからさっき言ったこれパイプインスペクションシステムは I have watched, I have shown これ見せたでしょ。それから、これは普通のパイプラインシステムは very very smooth because oil and gas is also usually flowing, so the only inspecting is only the welding conditions and also the thickness of the pipe. Thickness of the pipe is tested, so therefore it's good. And this is the University of Twente. The project is using more smaller diameter pipe. Inspection is a task of their project. And this is one unique product by CMU's laboratory. It is ちょっとこれ見ますか。
Magnetic. Like a hook.
まあフッキング、only フッキング。で、このディザスターシティでテステル。ディザスターシティはテキサスにあるディザスターシティというのはこのディザスターコンディションズテストフィールド。このスネークロボットがこうムーブ。このスネークライクこのウェイビングしながらこうムーブフォワード。でなんか犬にドッグにつけてドッグがこのパイプの中に入っていって、でそこで置いてでそこから、スネークロボットstart to move. ロボット detached from the rescue というのがあったりとかしていますね。で、このリアルニュークリアパワープラントでもなんかテストしましたよ。です。 で、アザーなんかオープンエアとしてはこのパワーエレクトリックパワーディストリビューションシステムのこのアイソレーションリプレイスメントとかトランスレーションアタッチメントとかこのトランスファーインストレーションとかインシュレーターリプレイスメントということでアクティブライン is used so therefore when some human worker is done sometimes attached to this distributed line and make some injury or damage or sometimes it's killed. So therefore the remote operation system like this is developed in 1980s. The Kyushu Electric Power Plant is the collaborative who work with Yasukawa Electric Company, Yasukawa Company. And also this is the cable inspection system. Cable ね。In many cases, for example, the electric power plant, water electric power plant and the nuclear power plant is from the urban places. So inside of the mountain area or seashore area. So therefore, distribution line is necessary to provide from the generated place to the urban places. So therefore, the line どんなの？なんかまあこんなこんなやつとかあるじゃね、鉄塔が。タワーね、こうタワーのケーブルがあって、で、What is theちょっとこの絵がしょうもない絵でしたね。このタワーがあってこうやってさ、こうなってて3本線がこうあるでしょ。ディストリビュートラインがこうやってね。でこのケーブルのインスペクション is necessary ね。なんかダメージとかウィークンとか necessary to inspect ちょっとこれこっちいいや、はい見ましょう。
The X-Flyer is a semi-autonomous robot used to inspect high-voltage transmission lines. Nowadays, what people do is either they use helicopters to check the lines from the top,
これちょっとわかりません。こっちにしましょう。こっちの方がよかった。Very high voltage transmission line のインスペクションだよとか言って、でこういうトランスミッションラインのインスペクションで、こういうインスペクションラインで、ほら、human worker is doing ね、presently. But to replace that human worker, this robot is developed. まあこういうロボットですよ。こういうロボットが人がやってる human operator, human worker is doing just checking task presently. But this inspection robot is replace a human worker to inspect the このケーブルコンディションでね、このでだからここら辺のトゥールを go over through these obstacles, and also one very big problem is this kind of hooking place should overcome and go to the next rope. So わかります？だからここでぶら下がってたのはこっちに to move this ねということのなんかそういうシステムを作らなければ continuous work cannot be achieved. So therefore, some special mechanism is necessary to develop.
So it's a very slow transmission of electricity. It can move on line obstacles while traversing the line of 50 kilovolts, for example. When the robot comes up against obstacles while traversing the lines, it can manipulate its center of gravity to move around them. There is a huge number of obstacles to cross. There are cable spacers. They are used to keep the distance between the lines constant. And those are still more or less easy to cross. But when we reach the tower, we have the suspension clamp, which is basically a metallic tool that is hanging the wires. And we have to find a way to cross that to continue to the next tower. So this is one of the strong points of X-Plane. It was developed in order to be able to do some, we call them acrobatic motions on the lines to overcome the obstacles and continue inspecting. So for
だからこっちからこっちをこう上げて to move here and again it is hanged from the next cables. Yes, gravity balance control is necessary.
Continuously recording a 360-degree view of each line. It also records GPS information as well as the distance from the tower, so that any defects are not only easy to locate, but also so operators can track the deterioration of the lines over time. After inspection, the data is automatically processed on the ground, and any anomalies found, such as rust, defects, surface damage, or line diameter changes which can be indicative of internal corrosion, are flagged for inspection.
まあいいやということでねまあ2つなんだけどこの2つできて片っぽリリースしてムーブフォワードして片っぽこっちに行ってこっちをリリースしてムーブフォワードしてこっちをくっつけるとかいうようなことをして to overcome this tower obstacle っていうような、まあ、メカニズムを開発するっていうのはこっちはカナディアンカンパニーですけどケベックカナディアンカンパニーのやつだけど This is similar mechanism also developed はいこれはアンマンドコンストラクションなんだけどアンマンドコンストラクションのビデオはたくさんあるんだけどまあこれはちょっとスキップしてこっちの方が面白いですねこれはもうあるみたいちょっとまあいいやラジオコントロールだけどまあ OKまあ、これもスキップしてこの two-arm reconstruction machine も also developed like the manipulator system これジョイスティックオペレーションなんですよあとは福島プラントのこういうのとかあとこれはクローラーになんかスイングアームが both sides forward and back side is attached and for the after the disaster this kind of inspection robot is developed. One is a Toshiba's robot, the other is a Honda's robot. This is Mitsubishi Heavy Industries robot, like this. And this is Hitachi's robot. And it is successfully done the inspection of this water inside of the water's inspection can be done last month. これまあいいやでこれがプレゼントコンディションなんだけど
A severe accident occurred at the Fukushima Daiichi nuclear power station on March 11, 2011. Thanks to the support of numerous partners, we have been making progress toward the completion of its decommissioning. We would like to show you what the power station looks like now, while looking back to the time of the accident. Units 1 through 3 were in operation at the time of the accident. They lost all power and their reactors could not be cooled. As a result, the fuel melted and a large amount of hydrogen gas was generated. This led to hydrogen explosions in Units 1, 3, as well as 4, which was connected to Unit 3. Currently, all units have been brought under control and are being stably cooled. This is the Unit 1 building at the time of the accident. At Unit 1, all panels of the cover over the reactor building, which were constructed to prevent the dispersion of radioactive materials, were removed in November 2016. Preparations for fuel removal are underway. At Unit 2, the impact of the hydrogen explosion forced the upper side panel of the reactor building to open, and as a result, the hydrogen was released outside. This panel is now closed to prevent the dispersal of radioactive materials. In addition, preparation for fuel removal is underway by dismantling the building top. At Unit 3, the largest piece of rubble in the spent fuel pool was removed for fuel removal. Now, preparation is underway for installation of the building cover and fuel handling machine.
今カバーを作っていて、それでフューエルハンドリングマシンをその inside of this cover it is now under construction。まあいいですよ。3まで見ればいいです。まあ1、2、3が severe conditions especially。Yes。ちょっとあとはtwo slides remaining about the aerial vehicles。まあこれはクワードaerial vehicles is also because also the 福島 some aerial vehicle is also will be used。この例えばクワードタイプvehicle とか or balloon type vehicle is also under research and development now。ではこれはマイクロソフトサーフェスジオみたいな。
What we're really interested here is human-robot interaction. With search and rescue, how do people use a robot that's really far away from them, and how do they get the information about what that robot sees, and how do they understand what's around that robot?
So the Dream Controller project, what stood out for us was the amazing combination of a surface computer together with robotics in a rescue situation.
During Hurricane Katrina, we had an apartment complex that otherwise would not have been searched, and so we were able to set the robots up and run it through a building and search that building in a way that wouldn't have been able to have been done otherwise.
Certainly rescuers now go into very difficult situations, but wouldn't it be much better to send a robot in there, because if the robot's destroyed, well, it's just a robot. It's not a person.
And what the user does, they walk up to the Microsoft Surface and they place their hand just very naturally down on the surface. Our algorithm then goes through and figures out each of their fingers and then actually paints a joystick up underneath their hand. And then just like you control an Xbox controller, you're controlling look on one hand and then drive on the other hand, and then so you move the robot through the world just like a real character in a video game.
What I really love about the collaboration with Holly and Mark is that they've done a very interesting mashup of two of our most exciting technologies. The
まあいいや、ということで、マイクロソフトサーフェスはなんかオペレーションインターフェースとして使ってますよっていう感じです。あとは、まあ、ここには、ペンシルバニアユニバーシティのグループのエアリアビークルがあって、あとはもっとサクセスフルクワードタイプはファントム DJI でしょうけど、そいつのプロモーションビデオがいくつかあって、で、and also the more high density images, the Hero 4とか Hero presently Hero 4, Hero 5 is now launched like this。なんか見る
GoPro inicia video.
So we have a dream at GoPro, which is to build the invisible camera. That's a camera that's so light, so small, so convenient to use, that you forget that you're using it, but without sacrificing any of the performance. And that's what we achieved this session.
You really get everything that you would want in our best camera, but in a tiny little package that fits in your pocket.
The Hero 5 session doesn't get any simpler for the user. I mean, it's one button on, record, super simple. We're trying to make it easier for people to capture great moments, not miss them.
One of the great new features on it, voice control.
GoPro 拍照 GoPro takes photo
GoPro 影響力。
The beauty
あ、今ボイスコントロールも入ってる。
is we want you to be in the moment. We want you to have a hands-free experience.
まあスタートストップだから
Accurate, and it works, and it's going to make sure that you don't miss those moments.
オーダープルーフ
Don't be fooled by its incredible design or its small size or its lightweight. This is the most durable GoPro we've ever made.
We wanted to make it waterproof right out of the box. There's a trust that comes from a camera that doesn't need protection. Allows you to grab that camera whenever you want to head out and know that it's going to survive the ride.
With a phone, you don't want to drop it. This thing, it's meant to be dropped.
You only have to use this during a rough and tumble activity to realize this thing is endearingly a cockroach. Incredibly difficult to kill in a session.
まあこれは主にはだからこういうこのビークルに乗っけるためにヒーロー4っていうのをまず最初に
Life is either an incredible adventure or
こういう撮るために買ったんですけど、まあいいです。ちょっと DJI のビデオ見ますか。
What do you need for incredible aerial imaging? A brilliant camera, an aircraft you can trust, and the intelligence to make every shot cinematic. The new Phantom 4 Pro has all this and much more. The Phantom 4 Pro camera has an f2.8 aperture, mechanical shutter, and large 1-inch sensor. Coming together to make brighter, more detailed imagery. Record cinematic 4K video at higher bit rates with more advanced compression and a wider dynamic range. 4K 60 frames per second recording gives you stunning, detailed, slow-motion aerial video. The Phantom 4 Pro is as adept at stills as it is with video, capturing every detail at 20 megapixels. Its mechanical shutter eliminates rolling shutter bending. Grab the perfect moment using burst mode. All of this makes the Phantom 4 Pro the most advanced aerial camera ever found in the Phantom series.
The Phantom 4 Pro is now a huge step forward. I'm taking photos of the lava when it's darker out and the glow of the lava is coming off of it. The image sensor that's in this camera now is 1-inch sensor, 20 megapixels. That extra dynamic range allows me to really get everything into one shot. In landscape, that's extremely important.
ということで、まあ、最近のリーセント DJI のプログレスはオンリーイメージカメラです。ということで、今日のコンテンツは all of them, but what I want to say is field application. Yes, various field application is there for the robotic systems, and there are many kinds of mechanisms is research and development.